Okay, good morning, everyone. This is our first ever lesson. Wow, that's pretty scary. I'm going to make you a couple of promises. One, I'm going to try not to suck. Two, I'm going to try to get better each time I do it. And three, I'll try to keep it as short as possible. Okay, so today this is lesson one of our new unit. The new unit is on linear relations, which basically means plotting lines on graphs, but we'll see that as we go along. We've got 5 things I want to look at today. One, I want to take a look at what a rectangular coordinate plane is. That's this guy. I want to plot an ordered pair. This will feel very familiar to you from science class. I want to talk about linear equations and the slope-intercept form. I want to plot a line using slope and y-intercept, and I also want to plot a line from 3 ordered pairs. So let's get going. If my voice starts to give out on me, I'm sorry, I'm still fighting this cold. Hopefully I'll make it through. Okay, a rectangular coordinate plane is this graph that you see. You also hear it called a Cartesian plane, but it has a whole bunch of different attributes, and we're just going to touch on them quickly so that we're all talking the same thing and using the same system. First, just like your science class, there's 2 axes, an x and a y axis, and there are positive and negative values for those. So this is actually the positive x, and this is the negative x end, and this is the positive y, and down here at the bottom is the negative y on the axes. There are 4 quadrants that we are using. This guy up here in the top right is quadrant 1, and basically what that means is that it represents the positive x and the positive y values of the graph. As we go counterclockwise, this is quadrant 2, and it represents the negative x and the positive y values on the graph. This is quadrant 3, and it's negative and negative. And this is quadrant 4, and it is positive and negative values of x and y. At the point where the x and the y axes cross, that's called the origin, and it represents the x and y values of 0 and 0. This pair of numbers is called an ordered pair, and it is always, always, always written in the order x and y. So if I write something like 4 and 3, that is 4 for the x and 3 for the y. Okay, so on this rectangular coordinate plane, we can plot a point like 3, 4. And to do that, we go over 3 units in x and up 4 units in y, and that is the point 3, 4. Please remember that it's always x and y, because something like 4, 3 would be an entirely different point from the one that we just plotted. All right, linear equations. So linear equations are the equations used to plot a line, and linear refers to the fact that the exponents on the variables will be 1. Nothing will be greater than 1 as far as the exponents go. There's lots of different forms that we can write linear equations in. We'll take a look at some of them as we go. Linear equations allow us the ability to create points, and those points can be joined together to form a line. And we'll have to do some reordering of formula during this unit, like we did a couple of units ago where we had to rewrite an equation to get one variable all by itself. So we'll need that here in this unit as we go along. So this is the first form of an equation that we're going to look at, and it is called the slope-intercept form. And I want to break these parts down for a minute. The m right there, that is the slope of the line. And this b, that is the y-intercept. And the y-intercept is the point where the line crosses the y-axis. The y and the x are just the two variables that represent the y and the x-axes, and we'll use those as we go along. Okay, so using the slope-intercept form, we can plot lines. We just talked about the fact that the x and the y are the axes on the coordinate plane, and the m is the slope, and the b is the value where the line crosses the y-axis. That's all great. The next question I have for you is, what would be the value of x at the y-intercept? Well, if I draw any line on here, and I take that line through a point where it crosses the y-axis, the point where the line crosses the y-axis has a value for both x and y, and you can see that the value of x at the y-intercept will always be 0. And that's true if we're talking about the x-intercept. I guess it's true in a similar fashion if we were talking about the x-intercept. The value of y at the x-intercept, which would be the point where the line crosses the x-axis, the value of y at that point would be 0. Okay, so let's plot a line using this method. We're going to do the slope-intercept form first. And so here we have an equation, y equals 1/3 x plus 3. Remember that 3 is the point where the line crosses the y-axis, the y-intercept. So I'm going to plot a point right there, and that would be 0, 3. That would be its ordered pair. The 1/3 is equal to the slope of the line. And the slope is or can also be written in the form the rise of the line over the run of the line. So to show you what this looks like, what I'm going to do is I'm going to go up 1. So the rise, that's this guy right here, is up 1. And I'm going up because it's a positive value. And the run, I'm going to go over 3. So I'm going to go 1, 2, 3. So from the y-intercept, I went up 1 and to the right 3, and those 2 points allow me to plot a line. And we put arrowheads on the end of the line because that line continues off into infinity in both directions. So that's a little bit odd, but we'll look at that again as we go along. Basically, we plot the point where the line crosses the y-axis, the y-intercept, and then we use the notion of slope, being the rise over the run, to figure out where the line is heading. You'll also notice that any positive slope, no matter what values you have for the slope, will go in this lower left to upper right direction. And if we had a negative slope, it would go the opposite. It would go in this direction. And we'll look at that a bit more as we go along as well. Oh, look at that. So let's say that we had the same formula, y equals negative 1/3 x plus 3, and I was going to plot that. I would go up to 3, that's the y-intercept, and in this case I would go down 1 and over 3. And I go down 1 because it's a negative value there, and that gives me a line running in this direction, and just as I mentioned, you can see that it's the opposite of a positive slope. Okay, so you could also have a formula like y equals 1/3 x minus 5 or minus 3 or something like that. And when you see that, please make sure that you include the negative sign with the numerical value. And in that case, I'd be plotting this y-intercept down below the x-axis. Okay, so for this method for plotting a graph, we're going to plot 3 points. And this is going to feel a little bit like your science class, where we're going to draw up a little x and y table, and we're going to pick any values that we want for x. Doesn't really matter. That's going to give us y values because we're just going to solve the formula. And those points we can then take to a graph and we can plot to get our line. So this is a different method of plotting a line on the coordinate plane. So to make our life easy, the first one that I'm going to plot is an x of 0. Well, I can see that y then becomes 4 onto 0 minus 5, so y equals minus 5. That's super easy. And just because I want to make my life easier, I'll pick a value like 2. So y equals 4 onto 2 minus 5. So that's 8 minus 5. That equals 3. And if I want to, I could pick something like, well, let's say I could pick -1. Any value will do. It doesn't really matter which ones you pick. And so that gives me a value of -9. So, okay, so there's my points right there. And I've taken those points and I've transferred them down here. Oh, I should make that a -5. That doesn't go there. And so I'm going to go and plot this, and I'm going to say 0 and -5. There's my 0 and -5. And 2 and 3. There's 2 and 3. I should write these in. And 0 and -5. And oops. And I'm going to go to -1 and -9. There we go, -1 and -9. And I can take those 3 points and I can create a line. Now, could I have done this out of 2 points? Sure, I could have done this out of 2 points. But the problem with doing it out of 2 points is if you make a mistake, there's no way of knowing. If you do it out of 3 points and you get some points stuck way out over here, well, it's pretty obvious that you've made a mistake somewhere in your calculations. You can go back and figure out where. It's a nice way of checking. If you do 3 points and you've made a mistake somewhere, they will not line up. So always do 3 points. It's just a nice, easy way of making sure that you did it right. Okay, so that's the lesson. I may redo this. We'll see. We'll talk about it in class tomorrow. Please take notes on what we've got here, and that'll do.